What if we could send tomato plants to space that didn't need light to grow? A new experiment flying to the International Space Station won't get plants into full darkness, but is looking into a way to reduce space plants' need for photosynthesis to produce food for future space travelers. Which could mean more food for less energy, which is a good recipe for long-duration space trips. It's been a while since I gave y'all a space plant update, so when I saw this study known as Rhodium USASA Night was launching later this month, I knew it was time to return to the latest in the space plant science saga. So, when you think of a typical plant, you think of it using sun and carbon dioxide to produce its own food through photosynthesis. But not all plants work like this. Similar to us humans who can't point our leaves towards the sun and make our own food, heterotrophic plants must find their fuel from other sources. One of the most famous examples is the Venus flytrap, which digests insects and arachnids for energy, but others even get their fuel from dead plants and animals, or even parasitically stealing it from other plants. And while plants growing aboard spacecraft aren't relying directly on sunlight, they are relying on artificial light created in grow systems, some of which are powered by solar energy. So, this new space station experiment is analyzing if the amount of light and energy needed to grow genetically modified tomato plants in space can be reduced by instead providing them with a direct form of food: acetate. Studies on Earth have found that some genetically modified plants can take to using acetate to supplement or replace natural photosynthesis, basically directly taking in food rather than the materials needed to make food. But we have many experiments telling us that microgravity changes a lot of factors about how plants behave. Scientists will compare the germination and growth of the modified plants in space to ones grown in the same conditions here on Earth, minus the factors introduced by space, like microgravity. And then they will investigate if acetate can be used to supplement plant growth despite reduced photosynthetic capability. So be sure to keep an eye on SpaceX's 30-second commercial resupply mission launching to the space station later this month to see this space plant study kick off.